Hello and welcome to the next lesson in the evolution of the delegate within the C# language here in the Advanced C# course brought to you by Tuts Plus. Now in this lesson I'm going to build upon the momentum that we started in the previous lesson when we introduced the concept of delegates, and now we're going to take you to the next level with the introduction of the concept of anonymous methods that we were given within the C# language version 2.0. So let's go ahead and jump into some code, and I'm going to show you how the concepts from the previous lesson of raw delegates evolved into this new concept of being able to save some keystrokes and allow you to do things a little bit quicker with anonymous methods. As you can expect, here we are back in Visual Studio. I will create a new project, console application, and let's go ahead and start things off by where we were at in the previous lesson. So we ended the previous lesson, we had created a delegate with a void return type. It had a name of operation and it took in an integer with a num name, and then within our class program we had a static void double method, if you recall, that took in an integer num, and then simply did a console write line with a little bit of formatting in it to make sure that we still know what our inputted number times 2 is equal, just to be sure. And it looked a little something like this. We had num times 2. We'll save this, and now within our static void main method, we merely created a new instance of our operation. We called it op, we set it equal to double, and then we passed this into another method and then ultimately executed it with the number 2. So we'll save this, Control F5, and there we go, just where we were in the previous lesson. 2 times 2 equals 4. Great. But that seemed like a lot of work, really, to get to that point. So we had to declare our delegate, then we had to write our method that was going to house the logic or the operations to which we were going to assign to our delegate. Then we instantiated our delegate, assigned our method to it, and then we executed it. So while this is absolutely doable, and you can continue to do this all the way up into the current version of the .NET framework and C#, it's getting a little dated, and Microsoft has gone through a lot of effort in order to lessen the struggles of working with these delegates, because you start to see them more and more in the development of components within the .NET framework, as well as custom-built components by you and I. We need to be able to do this a little bit quicker and a little bit easier. So in C# 2.0, Microsoft gave us the concept of anonymous methods, and really what anonymous methods allowed us to do was to be able to write these delegate methods, these expressions, in line. So we didn't have to name them, which is really where the concept or the thought of anonymous comes from, where in this case we're naming this method, we're calling it double, and then we're assigning it to our delegate operation. Anonymous methods allow us to skip this whole named declaration of this method and merely write the concept of this expression in line. So let's take a look and see how we do that. So really it's quite simple. So instead of having to assign double or assign a pre-existing method to this delegate, we can specify that we are going to set the operation equal to a delegate. And now the delegate is going to take an input parameter very similarly to how we've defined it up here. So we're going to do an open paren. We're going to specify that it is an integer, and it is a num, which is going to be the name of it. And then within curly braces, we can put in our logic. So I can merely cut this out of our method here, cut, paste it into our curly braces. I can now get rid of this entire static void double method, and now I can save and build my project, and it will build, and I can Control F5 and run, and we will get the same result. So this is kind of nice. We really cut out several lines of code here, and we were able to do it all in line. So we've specified the delegate, just as we've done on top. The same signature here, it's got an input parameter of a num, just like we have here. And we have the logic within the body or within the curly braces. So we could continue to build upon this. And if you notice, we do have a semicolon at the end of this line. Well, that means this is truly a method. If we wanted to format this a little bit differently to make it look a little bit more that we're used to, we could absolutely do that. We could drop these curly braces down a little bit, and now we're starting to actually look like the method that we did before. And I could add in more operations in here, as many as I want actually. So I could put a few more of these in here, and I could even change this operation to be times 3 times 4 times 5, and simply change these values over here, times 3 times 4 times 5, save, and run. And we're going to get all of the results. So really, this is exactly what I said. It's an anonymous way. You don't have to name this method, because really, at the end of the day, this is truly a method within these curly braces. We can simply define it inline, assign it to our delegate operation, and then pass it around and work with it as we did before. So this is kind of a nice optimization of the C# language to allow us to work with these delegates in an anonymous way. And of course, these don't have to be all void operations as well. We could have this return an integer, and then we would simply change our definition here. We could say that this is going to return num times 2. And now that we have this operation, this delegate, this anonymous method assigned to our operation, we can now execute this operation and get a value out, value equal to op2, and then we could do a console write line of value. We'll save, control F5, and there we go. We get 2 times 2 equals 4. Okay, pretty nice. So as you can see, you're given a lot of flexibility with this concept of anonymous methods and the ability to declare these methods in line and pass them around still as you would before, without having to write this extra method code down here if you want. Now, there's a little bit of a gotcha here. You really do have to watch yourself with this. While there are no limitations to the amount of lines you can have within these anonymous methods, I would definitely advise you to keep it a little bit shorter. Keep it to 2 or 3 at most, because if you start writing full business logic of 20, 30, 40 lines, or heaven forbid, even more than that within these inline anonymous methods, your code is going to get increasingly difficult to read. So I would definitely keep it simple when you're working with these anonymous methods, and maybe just stick with 2 or 3 lines, and that should be more than enough. If you find yourself having to do more than that, you should probably think about using a different construct, or maybe just sticking with the typical method invocation that you would normally. All right, so now what I'm going to do here is I'm going to back up a few lines here till we get to basically where we were at initially when we created this anonymous method. Now, the way that we did this is we specified delegate, we specified our input parameter, and then we did our console write line. Now, within the advent of C# 3.0, we were given the next evolutionary step of delegates and anonymous methods, and it took us into the world of Lambda expressions. Now, Lambda expressions are definitely a very deep topic, and you could spend a lot of time in several lessons, or possibly even a full course, learning about Lambda expressions and expression trees and things of that nature, but some of that I'm going to leave to you for your own investigation outside of this course. But I'm going to give you a little bit of an introduction to what Lambda expressions are and how that takes this concept of delegates and anonymous methods to a whole nother level. So this is still a fairly simple operation that we're working on here, and if you put it all on one line, you know, it's not too bad. There's not too much going on here to make it unreadable, but once again, there's still a little bit of extra fluff out here that is kind of taking up some room. So we have this word delegate, we have this input int num, and we have a console write line. So there's still a little bit extra going on here that, in all honesty, we really don't care about. So if we could even trim this down a little bit more, I think that would be even a little bit nicer for us, especially when we start working with things like events in the coming lessons and other things like link, which we're going to get to in another lesson. You're going to see the usage of these lambdas quite often, so it's definitely a good time for you to start understanding what they do and how they work. So the concept of a lambda really, once again, shortens this concept of anonymous methods, and the way that it works is we can now drop out this word delegate as we no longer need it anymore. Okay, so we do still have an input parameter, and that's fine. And we do have the body of what we need here, and that's fine too. And the way that we tell the compiler that we're working with a lambda or a lambda expression is by specifying the lambda operator, which is nothing more than an equals and a greater than sign. So if you kind of look at it, it looks a little bit like a smiley face, I suppose. But the way that it works is you specify the input parameters within parentheses. And really, the parentheses are only required if you have multiple input parameters. So you could get rid of these. And then if you are writing code in such a way that the type of the input parameter can be inferred from the code that you're writing within your block, you can get rid of the type as well. So now here we go. We have the input parameter of our lambda expression is num, and then we have a console write line operation within our what used to be our anonymous method, which is now a lambda expression, which is still within the body of this method, which is within curly braces. And now we can do save, Control F5, and we still get the same result. So this is kind of the next step in where we're going with the concept of anonymous methods. We were able to trim it down even more into this lambda expression. So definitely something to pay attention to, as we're going to see quite a bit of this in the coming lessons, as I mentioned before, when we're talking about events as well as link. So play around with this a little bit, see how it feels, see if you can get used to it a little bit, and I definitely think you're going to find it to be very useful. Now, one other thing I want to touch on before we end this lesson is, wouldn't it be nice now too if I didn't have to create a declaration of my delegate in another place and then use it here? Wouldn't it be nice if I could just do everything within this one line and then pass that around just as I normally would? Well, we absolutely can, and that was brought on by the concept of generic delegates. And if you've ever heard of the two words action and func, then this is going to be kind of a review for you. But if you haven't, then definitely stick around and let's work through an example of this. An action and a func are very similar things. They're generic delegates, action and func, but they differ slightly. And the difference is that an action is a delegate. So because it's a delegate, you can assign both anonymous methods and lambda expressions to it. But the difference is that an action does not have a return value and a function does, or a func does. So let's go ahead and rewrite this example using generic delegates. So we'll comment this out, and I will delete these and delete this. So there we go. Now we're starting from scratch, and I know that we are going to want something that's called op, and I want to pass a 2 into it, and I want to get this same concept here. So the way that we do that, since there's nothing being returned in this lambda expression, I really just want to execute it and not have anything come back, and the way that we do that is via an action. So I can specify action, it's generic, and as you see, there are 16 overloads in here. All of these overloads are generic parameterized types that you pass into the action. So you can see there's T1, T2, and it will go all the way up to 16. So in the current version of the .NET framework in C#, you can have up to 16 input parameters on an action, or ultimately on a delegate, anonymous method, or a lambda expression. So for our case, we only really need one. That's that one input parameter, that one int. So we're going to say that the input parameter is an integer, and now we can assign that equal to the input is num. We have a lambda expression. It's going to be a console write line, and it's going to have the same body as we had before. So I'll just copy this out. I will paste it in here. I will close it off, and I will assign our action a name. We'll call it op. We'll save, and now we should be able to Control F5 and run this as we did before. So that's kind of nice. So now I can declare all of my delegate type operations, anonymous methods, or lambda expressions all in line, and assign it to an action type and pass that around all within my code, and I don't have to do any extra declarations or initializations of delegates anywhere else in my code. All right, that's kind of nice. And then in the other example I was working with, I was doing something where I was simply returning a value of whatever I passed in times 2. Now, if you want to return a value, then you have to use a func, which is once again the generic delegate type that allows you to return a value. And as you can see here, there are 17 overloads, and this is a little bit tricky and it takes a little bit getting used to and working with, but by default it only takes an output parameter, an out parameterized type, and that is the first thing in there. So if there are no input parameters, you still have to specify the output type. Now, this also can take up to 16 input types, as you can see here, and the out or the return type is always the last parameter within the generic parameters. So if I do something similar to what I was doing before, I had an input that was an integer, and I also had an output that was an integer. So now the compiler is going to assume that the first type is the input parameter, and the second type is the output parameter. So we'll call this double, and it's equal to x is going to be our input. Then we are going to specify our method body, and we're going to return x times 2. It's not going to like my name here. We'll specify double. We'll save that. And now we can execute console write line. We can execute double passing in 2. And we'll save, Control F5, and there we have it. So now we can write these generic delegates that take up to 16 input parameters and just do some sort of expression, which would be the action that we've had right here. Or we could also create a generic delegate that takes in up to 16 parameters and returns an output parameter, which is specified by the func. And then we can treat all of these inline and pass them around just as we normally would with any other object. So these are very cool things. Definitely play around with these. They're a lot of fun, I think, and it really lessens some of the code that I have to write, and I can really modularize some of this method or some of these method functionalities and just pass them around as I would, like I said in the previous lesson, as kind of plugins or the ability to create more extensible code. So now that you have that kind of under your belt, in the next lesson I'm going to take you to the ultimate peak of where we see a lot of these delegates, anonymous methods, and Lambda expressions, and that is in the world of events. And I'll see you then.